6 minutes ago, somewhere under the dust of the moon, the ground moved on its own. Most people expect the moon to be a dead, frozen rock that has not changed in a billion years. Stick with me, because that is not what the evidence actually shows. And before we go further, hit subscribe so you get the next hidden space story the moment it drops, because this channel digs up the discoveries that never made the evening news. Here is the strange part. The moon has no wind, it has no rain, it has no shifting oceans or moving continents like Earth does. And yet, again and again, seismic instruments left behind decades ago have picked up something shaking underneath the surface. Something is cracking the moon open from the inside, slowly, quietly, and scientists are still piecing together exactly why. This is not a ghost story. This is real data, collected by real instruments, studied by real scientists at real institutions. But the full picture only came together recently, and part of it points straight at the same region where astronauts are scheduled to land again. Let me walk you through this from the very beginning, because the beginning is where most people get it wrong. Think about the last time your house made a strange noise at night, a creak in the floorboards, a pop from the walls settling as the temperature dropped. You probably did not panic. You probably just noticed it, filed it away, and went back to sleep. The moon has been making its own version of that quiet, settling creak for a very long time, and almost nobody was listening closely enough to notice. By the end of this video, you will understand exactly what is causing that creak, why it took scientists decades to piece it together, and why the timing of this discovery lines up almost perfectly with plans already underway to send people back to the lunar surface for good. Now let us start from the beginning. Most people believe the moon is geologically dead, meaning nothing inside it moves or changes anymore, kind of like a cold stone sitting in your driveway. That belief made sense for a long time, but it turns out to be wrong, and the reason it is wrong took nearly 50 years of quiet, unglamorous work to prove. That belief is not silly, by the way. It is exactly what most textbooks used to say, and honestly, what a lot of textbooks still imply without meaning to. Earth has a bubbling, moving inside, plates that grind against each other, volcanoes that erupt, and an active magnetic field. The moon looked like none of that. No visible volcanoes erupting today, no obvious moving plates, just craters and dust, sitting there looking the same in every photograph ever taken of it. The story starts in the late 1960s and early 1970s, when Apollo astronauts carried a strange piece of equipment onto the lunar surface. It looked almost boring, like a small silver suitcase sitting on 3 legs. Inside, it was a seismometer, a device that listens for tiny shakes in the ground, the same kind of tool scientists use on Earth to detect earthquakes. At the time, almost nobody thought this device would matter much. The moon was assumed to be too quiet, too dead, too boring to shake. In fact, when the Apollo program ended in 1972, 5 of these seismometers kept recording data from the lunar surface for years, quietly humming along while the rest of the world moved on to other things. Nobody expected them to find much of anything. That is, the first piece of this story you need to hold on to. An overlooked, underestimated little machine, sitting alone on an abandoned world, kept recording anyway. And what it recorded sat mostly unexamined for decades. Boxes of tape and paper tucked away in archives, waiting for someone to come back and actually listen. The first surprise came from simply turning the old data back on. In the 1970s, when scientists first studied the Apollo seismometer readings, they expected to see a pattern similar to Earth. On Earth, an earthquake hits hard and then fades away fast, usually within a couple of minutes, because our planet is full of water and cracked, broken rock that absorbs the shaking quickly, like a wet sponge soaking up a spill. What they actually found on the moon was almost the opposite. When the ground shook up there, the vibrations did not fade in minutes. They rang on, sometimes for more than 10 minutes at a time, sometimes close to half an hour. Imagine hitting a bell with a hammer and having it ring, not for a second, but for the length of an entire television commercial break. Scientists compressed this discovery into a phrase that stuck. They said, "The moon rings like a bell." That single sentence became one of the most quoted lines in lunar science because it captured something almost impossible to picture otherwise. The moon is dry, it is made of tightly packed, unbroken rock, and dry, unbroken rock lets vibrations travel and echo for an extremely long time, instead of dying out quickly like they do on our wet, cracked planet. Let that sink in for a second, because it connects to something you already know. Think about the difference between clapping your hands inside a padded room full of soft furniture and clapping your hands inside an empty stone church. The padded room swallows the sound almost instantly. The empty stone church lets it bounce and echo. The moon, geologically speaking, is the empty stone church, and Earth is the padded room. Or think about it a simpler way, one you have probably felt with your own hands. Tap a wet kitchen sponge on the counter, and the sound dies almost instantly, soaked up by all that water and softness. Now tap a dry ceramic mug on the same counter, and the sound rings out sharp and clear, lasting far longer. The moon is the dry mug. Earth, full of water and cracked, broken rock, is the soggy sponge. That single comparison, the moon ringing like a bell, is not just a catchy phrase scientists use to sound dramatic in a press release. It fundamentally changed how researchers modeled the inside of the moon, because the way vibrations travel tells you something real about what material they are traveling through, whether it is packed tight and dry, or loose and fractured, or something else entirely. That first discovery reshaped how scientists thought about the moon's insides, but it also raised a bigger question. If the moon was supposedly dead, with no shifting plates and no molten activity pushing things around, then what was actually causing the shaking in the first place? Ringing like a bell is one thing, but something still has to strike the bell. This is where the story gets quieter and slower, and in some ways more unsettling. Because for years, nobody had a full answer. The seismometers picked up different kinds of moonquakes, some caused by meteorite impacts smacking into the surface, some caused by the moon simply flexing under Earth's gravity as it moves through its orbit. But there was another category that did not fit neatly into either explanation, and that category is where the real mystery lives. The second finding changed everything, and it came from a very different source, decades later. In 2010, scientists studying high-resolution images from a NASA spacecraft called the Lunar Reconnaissance Orbiter, running out of the Goddard Space Flight Center, expected to see a surface that looked essentially unchanged for billions of years, since the moon has no wind or rain to erode anything. What they actually found were thousands of small, young-looking cliffs called scarps scattered across the surface, some only a few tens of feet tall and a few miles long. These cliffs looked fresh, not billions of years old. In some cases, based on how few small craters had built up on top of them, possibly only a few tens of millions of years old, or in geological terms, practically yesterday. Here is the compressed version of why that matters. A cliff like that forms when the moon's crust gets squeezed and one section of ground shoves up and over the section next to it, like a rug bunching up when you push both ends toward the middle. For that kind of wrinkling to happen, the whole moon has to be getting slightly smaller, shrinking in on itself, the same way a grape slowly shrinks and wrinkles into a raisin as it dries out and loses volume from the inside. That comparison is not just a poetic flourish, it is the actual working model scientists use. As the moon's interior slowly cools down over hundreds of millions of years, it contracts, just a little, and the solid outer shell has nowhere to go, so it buckles and cracks, pushing up these small thrust-fault cliffs across the surface. The moon is not just an inert rock, it is closer to a slowly shriveling grape, one that occasionally creaks and shifts as it does. We are talking about a shrinkage of roughly 150 feet across the moon's entire 2,159-mile diameter over the last several 100 million years, according to estimates from the Lunar Reconnaissance Orbiter team. That sounds tiny, and honestly, it is tiny, about the length of half a football field spread across an object wider than the entire continental United States. But even a small shrink like that, spread across solid rock with nowhere to bend, is enough to crack the surface into cliffs. Here is the scale flip that makes this hit differently. Zoom all the way out, and the moon has been drifting through space for about 4.5 billion years, silent and pale in our night sky, since before there were eyes anywhere in the universe to look up and see it. Zoom all the way back in, and the very same world is still quietly cracking, millimeter by millimeter, at a pace slower than your fingernails grow. Have you ever wondered why a topic like this barely makes headlines even though it completely rewrites what we thought we knew? I would genuinely like to hear your take in the comments, because your comments are what tell me which hidden science stories deserve a deeper follow-up video next. Now here is where the two discoveries start to connect, and where the story stops being just interesting and starts becoming genuinely important. If the moon is shrinking and wrinkling, and if some moonquakes are strong enough to ring for half an hour, then the natural next question is simple. Where exactly are these quakes happening, and are any of them happening somewhere that matters to us right now? To answer that, a team of scientists went back through the original Apollo seismometer data one more time, but this time using modern computer techniques that did not exist in the 1970s. This kind of patient, unglamorous reanalysis is often where the biggest discoveries hide, buried in old numbers nobody had the tools to fully decode the first time around. In a study published in the journal The Planetary Science Journal in May of 2019, researchers led by Thomas Waters, a senior scientist at the Smithsonian Institution's National Air and Space Museum, working with the team behind the Lunar Reconnaissance Orbiter mission, reanalyzed 28 shallow moonquakes recorded by the Apollo seismometers between 1969 and 1977. They wanted to see if any of these quakes could be traced back to specific fault scarps on the surface. The third discovery puzzled scientists the most, and it is the one this whole video has been building toward. Researchers expected any strong quakes tied to these cliffs to be scattered randomly across the moon's surface, since the wrinkling process was assumed to happen more or less evenly everywhere as the interior slowly cooled and contracted. What they actually found was that at least 8 of these quakes lined up closely with known fault scarps, and several of the strongest ones clustered near the lunar South Pole, the exact region where NASA's Artemis program has targeted future crewed landings. One of the quakes studied, recorded on January 13, 1975, is estimated to have been as strong as magnitude 5 on the scale we use for earthquakes here on Earth, strong enough to be felt clearly, strong enough to potentially damage lightweight structures. Picture magnitude 5 for a second, in a way that actually means something to you. On Earth, a magnitude 5 earthquake is strong enough to crack plaster on your bathroom wall, knock picture frames off a shelf, and send people running outside their homes in fear. Now picture that same amount of shaking happening on a world with no rescue teams nearby, no ambulances, and dust so fine and sharp it behaves almost like ground glass. And remember the earlier discovery, the one about the moon ringing like a bell? On Earth, that magnitude 5 shaking would rattle your kitchen cabinets for maybe 10 or 20 seconds before settling back down. On the moon, because the ground is so dry and so tightly packed, that same shaking could keep rattling for many minutes afterward, a slow, fading tremor instead of a short, sharp jolt, exactly the kind of prolonged shaking that stresses out rigid structures far more than a quick jolt ever would. That combination is what actually worries engineers, not the strength of any single quake by itself, but the length of time the shaking lasts. A short jolt, a building can often absorb. A long, drawn-out, repeated shudder, the kind the Apollo seismometers recorded again and again, is a very different engineering problem, closer to standing on a tuning fork than standing on solid, forgiving ground. That third finding is the part that makes this story feel genuinely dangerous, not in a dramatic movie sense, but in a very practical, very real engineering sense. Because it means the same region being planned for future lunar habitats and long-term human presence is a region where the ground has, at least a few times in recorded history, moved suddenly and violently enough to matter. Let us pause on sensation for a moment, because numbers alone do not capture what this would actually feel like. Picture standing inside a thin-walled habitat on the moon, wearing a suit heavier than a winter coat, when the floor beneath your boots begins to hum, a low vibration you feel in your teeth before you consciously hear it, and then it keeps humming, long after any quake on Earth would have already gone silent, because remember, the moon rings like a bell. There is also a strange kind of silence tied into all of this. On Earth, an earthquake usually comes with a low rumble you can hear through the air, because sound needs air to travel through, and Earth has plenty of it. The moon has almost no atmosphere at all, so even a violent quake would move through the ground in near total silence, a shaking you could only feel, never hear, unless you happen to be touching something metal that could carry the vibration. That kind of silent shaking is oddly unsettling to think about. Imagine feeling your kitchen floor shudder beneath your socks, but hearing absolutely nothing. No creak, no rumble, no bang, just pure, total silence wrapped around a very real, very physical motion. That is roughly what a moonquake would feel like to a future astronaut standing inside a lunar habitat, a violent event with almost none of the audible warning signs we instinctively rely on here at home. If this kind of hidden risk sounds like something more people should actually know about, would you consider sharing this video with one person who is curious about space exploration? Sharing helps stories like this reach people who are genuinely planning to follow the Artemis missions closely, and right now, most of them have never even heard the phrase moonquake. Let us widen the lens again for a second, because scale matters here, and it is easy to lose track of just how big and how small these numbers really are. The moon sits roughly 239,000 miles from Earth on average, close enough that Apollo astronauts made the trip in about 3 days. Its diameter is about 2,159 miles across, small enough that you could tuck it comfortably inside the borders of the continental United States with room to spare on both sides. And yet inside that comparatively small ball of rock, forces strong enough to crack solid stone into cliffs are still quietly at work, hundreds of millions of years after most people assumed everything up there had gone completely still. That contrast, a world small enough to fit inside a country, but active enough to still be cracking itself open, is exactly what makes this story so hard to shake once you actually understand it. Now compress the timeline itself, because that is where this story becomes genuinely uncomfortable. The scarps studied near the Apollo landing sites are estimated to be less than 50 million years old, and some of the quakes tied to them were recorded in the 1970s, meaning within living memory, within the lifetime of people who are still alive today watching this video right now. That is not ancient history. That is closer to breaking news on a geological timescale, arriving roughly a century after the last living dinosaur had already been gone for 65 million years. Now for the part scientists are genuinely still wrestling with. And I want to be precise about this instead of vague, because precision is what separates a real mystery from a manufactured one. Scientists will tell you they do not fully understand exactly how much the moon is still shrinking today, or exactly how active its deep interior remains. The moon almost certainly does not have the same kind of hot, actively churning molten core that drives Earth's much stronger and more frequent earthquakes. Some researchers, including scientists working with data from NASA's Grail mission, which mapped the moon's gravity field in 2011 and 2012, have proposed that a small part of the moon's core may still be at least partially molten, meaning partly melted rather than fully solid, slowly releasing heat as it cools. Others argue the shrinking could instead be driven mostly by the outer layers cooling on their own, with much less involvement from the deep core than originally assumed. This is still debated, and that is not a weakness in the science, it is actually a sign that the science is being done honestly. Nobody is pretending to have the full answer just to make a tidy ending. The models had predicted the moon would be essentially finished shrinking and settling by now, quiet and stable for the remaining billions of years of its existence, and instead the data keeps showing quakes strong enough to matter, happening more recently than anyone expected. Some scientists argue the heat driving all of this comes from radioactive elements slowly decaying deep inside the moon, the same basic process, though far weaker, that keeps parts of Earth's own interior warm. Others point to leftover heat from the moon's violent formation billions of years ago, heat that has simply never fully escaped. Nobody is claiming certainty here, and any script that tells you otherwise is skipping past the honest, unfinished parts of the story on purpose. In 2023, a follow-up study, also involving Thomas Waters and colleagues at the Smithsonian, along with researchers connected to NASA's Jet Propulsion Laboratory, or JPL, in Pasadena, California, used ground stability modeling to show that shaking from a nearby fault scarp could trigger destabilized boulders and landslide-type movement in certain permanently shadowed craters near the South Pole, some of the very same craters being eyed as possible sites for future water ice mining. The study specifically flagged the area around the Degerlache crater rim, close to some of the leading candidate landing zones for the Artemis 3 mission, as a place where boulder movement from ground shaking was a real, modelable possibility rather than a distant hypothetical. That is about as close as science gets to circling a spot on a map and writing the word caution next to it. Sit with that phrase for a second. Permanently shadowed craters. These are places near the lunar South Pole so deep and so oddly angled that sunlight has not touched their floors in possibly billions of years, cold enough that scientists believe water ice has stayed frozen there the entire time, a potential resource for future astronauts. And the newest research suggests the very ground around some of these ice deposits may not be as stable as anyone hoped. None of this means a mission is doomed or that engineers cannot design around it, and it is important to say that clearly. Engineers on Earth build in earthquake zones successfully every single day, using deep foundations and flexible materials designed to absorb shaking instead of fighting it. Cities like San Francisco and Tokyo house millions of people on ground that shakes far more often and far more violently than anything recorded so far on the moon. The point is not that this danger is unsolvable. The point is that it was almost completely invisible until patient scientists went back and actually listened to 50-year-old data nobody had fully understood the first time around. Knowing a risk exists before you build something is exactly the kind of quiet, unglamorous discovery that never trends online, yet it may end up shaping the design of every lunar habitat built for the next 100 years. Which brings us to something worth sitting with for a moment before we close this out. Would you say the biggest lesson here is that we underestimated the moon itself, or that we underestimated how much old, ignored data still had to teach us? I would love to know which one strikes you more, and liking this video actually helps tell the platform that stories like this deserve to be shown to more curious minds like yours. There is one more thread worth pulling before we bring this story home, and it circles back to something we touched on earlier, the idea of the underdog. Those 5 Apollo seismometers were never treated as glamorous equipment. They were small, unglamorous, easy to overlook next to the flags and the footprints and the moon rocks that got all the attention back home. For years, most of their recordings just sat there, quietly. But because those instruments kept working, kept listening, long after the astronauts who placed them had gone home and moved on with their lives, we now have a direct seismic record stretching back to 1969, an incredibly rare gift in planetary science. Most worlds in our solar system have never had a single seismometer placed on their surface at all. The moon has had 5, sitting patiently, waiting for someone to come back and actually pay attention. Think about that timeline for a second. These instruments were switched on during the same era when most homes still had rotary phones bolted to the kitchen wall, when a color television was considered a luxury item, and when nobody had ever heard the word internet. They kept recording anyway, faithfully, for years, long after the mission that placed them there had officially ended and NASA had shifted its attention elsewhere entirely. By 1977, budget cuts forced NASA to shut the seismometers down for good, and for a long stretch afterward, this recorded data mostly sat in storage, printed on paper strip charts and stored on analog tapes, the kind of format that eventually needed its own specialized machines just to be read back at all. Digitizing and cleaning up that old data took years of patient, unglamorous work by researchers who believed there was still something worth finding buried inside it. That patience paid off. Renee Weber, a planetary scientist at NASA's Marshall Space Flight Center who has studied this Apollo seismic data extensively, has pointed out that these decades-old recordings are still being mined for new discoveries today, more than 50 years after they were first collected, because the questions we know how to ask, and the tools we have to analyze old data, keep improving even when the equipment itself has long since gone silent. So here is where all 3 discoveries finally lock together into one picture. The moon rings like a bell because it is dry and solid, letting vibrations travel far longer than they would on Earth. The moon is slowly shrinking like a grape drying into a raisin, wrinkling its surface into thousands of young-looking cliffs as it does. And at least some of the quakes tied to that shrinking cluster, dangerously close to the exact region where humans are planning to live and work in the coming years. Individually, each of those 3 facts is a fascinating piece of trivia. Together, they form something closer to a warning label, quietly written into the ground itself, waiting patiently for us to notice it before we start building anything permanent on top of it. One more question before we close, and this one is simple. If a future Artemis astronaut is standing on the lunar surface when a moonquake hits, and the ground hums beneath their boots for what feels like an impossibly long time, what do you think should happen next in how we plan these missions? Drop your thoughts in the comments, because those comments genuinely help shape which mission updates and follow-up stories we cover here next. So let us bring this all the way back to where we started. At the beginning of this video, most people expected the moon to be a frozen, unchanging rock, a dead world with nothing left to discover beneath its dusty gray surface. That expectation, it turns out, was simply wrong, and proving it wrong took patient scientists, decades of quietly waiting data, and a willingness to go back and listen to something everyone else had assumed was finished talking. Here is the image I want you to actually carry with you after this video ends. Somewhere right now, in the freezing darkness near the lunar South Pole, inside a crater sunlight has not touched in longer than humans have existed, the ground is very, very slowly settling, the way an old house settles quietly at night, creaking just enough to remind you it is still standing, still shifting, still very much alive in its own slow, patient way. We opened by telling you the ground moved on its own, 6 minutes before this video began, and that felt strange, almost impossible, coming from a world we were taught to think of as permanently still. Now you understand exactly why that is true, not because of anything mysterious or hidden away in a vault somewhere, but because of physics, patience, and 50 years of quiet, careful listening that most people never even knew was happening. The moon is not the dead, silent neighbor we grew up believing it was. It is closer to something old and tired, still settling under its own weight, still creaking in the dark, long after everyone assumed it had gone completely quiet. And the next time you look up at it hanging there in the night sky, calm and pale and impossibly still from where you are standing, I want you to remember that somewhere beneath that silence, it is still very quietly moving. Think back to that house settling at night, the creak in the floorboards you barely noticed before falling back asleep. Multiply that feeling by a world 4.5 billion years old, hanging silently above your roof every single night of your life, and you start to understand why this story stuck with the scientists who uncovered it, and why it is sticking with you right now, whether you expected it to or not. Few people walking outside tonight will look up and think about any of this. Fewer still will realize that the same calm, silvery light falling across their yard is coming from a world that is still, quietly, actively shaping itself beneath the surface. But now you know. And once you know something like this, it tends to change the way you look up, even just for a second, the next time you happen to notice the moon hanging there in the dark. That is the story worth carrying with you tonight, not as a warning, but as a reminder. Some of the most important discoveries are not loud announcements. They are old, patient recordings, waiting decades for someone to finally sit down and truly listen.